For 2025, we need Fusaka on the layer 1 with pure DAS, ideally with 48 blob target. And then he follows up saying, let's aim to get a Fusaka testnet with these blob parameters running the day after Pectra goes live.
There's all these proposals saying like we should hard fork every 6 months or every quarter or whatever. This sounds good in theory, but imagine we're doing this, say, for the merge. And it's like, okay, we mixed this 6 months deadline. Do we just like ship a bunch of random, less useful stuff?
Random shit, yeah.
Obviously, it's still the highest important priority to ship the merge. If it's going to take an extra 6 months because there's something fundamentally hard about the merge, we should still be willing to pay that cost.
Welcome to Bankless, where we explore the frontier of internet money and internet finance. And today, we're exploring the next steps in the Ethereum roadmap. Ethereum is alive. It is an organism that is constantly evolving and adapting through a slow, iterative process of debate, deliberation, and rough consensus. And the Coliseum for where this all goes down is the Ethereum Alcore devs calls. This is where priorities are hashed out and EIPs are either marked for inclusion or cut and left on the floor. With me today on Bankless is Tim Beiko, who is a coordinator of these Alcore dev calls. He is right in the middle of everything, traffic controlling conversations and priorities from the various components that make up Ethereum, while also ensuring that things do keep on progressing. With the Pectra hard fork on the horizon, I thought it was time to get Tim on the show to give the Bankless Nation an update as to what is included with Pectra, as well as what's coming over the horizon with the next Ethereum upgrades, Fusaka, and then eventually Glamsterdam. And if these names feel both odd and familiar to you, they are, and we'll explain how these names of Ethereum software upgrades come to be in the first place. In this episode with Tim, we talk about Ethereum's increasing aggressiveness with scaling data availability and why scaling the Ethereum layer 1 is harder, how Ethereum's staking mechanics are getting an overhaul, and WTF is Ethereum object format, and what does it do for improving the developer experience on Ethereum. If you appreciate this podcast, please subscribe. If you already subscribed, perhaps also leave a rating or a review. Those 5-star reviews do help us get to the top of the charts so we can help the world go bankless. And if you are already a Bankless citizen who is listening to this on your ad-free premium RSS feed, make sure that you get the private RSS feed loaded up into your Spotify. The album artwork for every episode is just so incredibly pretty. Shout out to our designer, as well as all the early podcast releases and perks that come with your premium feed. Let's go ahead and get right into this episode with Tim. But first, a message from some of these fantastic sponsors that make this show possible. In the Wild West of DeFi, stability and innovation are everything, which is why you should check out FRAX Finance, the protocol revolutionizing stablecoins, DeFi, and rollups. The core of FRAX Finance is FRAX USD, which is backed by BlackRock's institutional BUIDL fund. FRAX designed FRAX USD for best-in-class yields across DeFi, T-bills, and carry trade returns all in one. Just head to frax.com, then stake it to earn some of the best yields in DeFi. Want even more? Bridge your FRAX USD over to the Fraxtal Layer 2 for the same yield plus Fraxtal points, and explore Fractal's diverse Layer 2 ecosystem with protocols like Curve, Convex, and more, all rewarding early adopters. FRAX isn't just a protocol, it's a digital nation, powered by the FXS token and governed by its global community. Acquire FXS through frax.com or your go-to DEX, stake it, and help shape FRAX Nation's future. Ready to join the forefront of DeFi? Visit frax.com now to start earning with FRAX USD and staked FRAX USD. And for Bankless listeners, you can use frax.com/r/bankless when bridging to Fraxtal for exclusive Fraxtal perks and boosted rewards. Introducing UNICHAIN. Built for DeFi and powered by UNISWAP, UNICHAIN is the fast, decentralized layer 2 designed to tackle blockchain speed and cost challenges. With this mainnet now live, you can enjoy transactions that are up to 95% cheaper than the ETH layer 1, all while benefiting from an impressive 1-second block time that will be getting even faster very soon. UNICHAIN is the first layer 2 to launch as a stage 1 rollup on day 1. That means it comes with a fully functional permissionless proof system from the start, increasing transparency and further decentralizing the chain. More than 80 apps are joining the UNICHAIN community, including Coinbase, Circle, Lido, Morpho, and Uniswap. You'll be able to bridge, swap, borrow, and lend, and launch new assets and more from day 1. Built by Uniswap Labs, the team behind the protocol that's processed over 2.75 trillion in all-time volume with 0 hacks, UNICHAIN truly enhances DeFi experiences with faster, cheaper, and seamless transactions, even across chains. And soon, the UNICHAIN validation network will allow anyone to run a node and earn by securing the network. Visit uniswap.org and swap on UNICHAIN today. The ARBITRUM portal is your one-stop hub to entering the Ethereum ecosystem. With over 800 apps, ARBITRUM offers something for everyone. Dive into the epicenter of DeFi, where advanced trading, lending, and staking platforms are redefining how we interact with money. Explore ARBITRUM's rapidly growing gaming hub, from immersed role-playing games, fast-paced fantasy MMOs, to casual luck battle mobile games. Move assets effortlessly between chains and access the ecosystem with ease via Arbitrum's expansive network of bridges and on-ramps. Step into Arbitrum's flourishing NFT and creator space, where artists, collectors, and social converge, and support your favorite streamers all on-chain. Find new and trending apps and learn how to earn rewards across the Arbitrum ecosystem with limited time campaigns from your favorite projects. Empower your future with Arbitrum. Visit portal.arbitrum.io to find out what's next on your Web3 journey. Bankless Nation, very excited to introduce Tim Beiko. He is a coordinator at the Ethereum Foundation. He's a central information hub for all the various components of the Ethereum protocol and helps kind of guide the hard fork process, hard fork upgrade process for Ethereum, as well as the Alcore devs call. Tim, welcome to Bankless.
Thanks for having me.
So I really want to kind of just get a download on the kind of the current state of thinking as it relates to EIPs that are going to make it into Ethereum. And of course, any informed listener would know that these go into Ethereum in chunks. We call these chunks hard forks. The next hard fork that we are currently preparing for is called Pectra. But then there are other hard forks that happen after that as well, such as Fusaka and Glamsterdam. We'll actually talk about how these names come to be. But maybe, Tim, maybe you can kind of just zoom out a little bit and kind of give us a lay of the land of what things seem to be being prioritized, generally speaking. So when we look into the updates that the Alcore dev meetings are discussing, what kinds of updates are rising to the surface? Like what is the ACD calls of Ethereum, Alcore devs calls? What are they prioritizing?
Thanks. Yeah. I'd say the first thing, which is kind of obvious to some people, but probably doesn't get emphasized enough, is security. So first and foremost, the thing that kind of differentiates Ethereum from other chains is just this like extremely robust approach to security. And in practice, this shows up as like the chain has never gone down. And there's an immense amount of work that goes into this. So if you're listening to like some random segment of an Alcore devs call, you're probably hearing people just like debate, is this thing safe? How is it going to break? And if it broke, why? And how can we fix it? So while this isn't like a feature as much as some of the other stuff we'll talk about, it's worth being mindful of this because it is kind of the thing that then dictates all of the other priorities. Like, why can't we do this specific thing that seems obvious? The answer is usually because there's like some security property we're trying to work through to make sure that it's actually robust when deployed on Ethereum. Yeah, but with that being said, I'd say like the most like prominent theme of the past year or so has been around scaling, both on the execution and consensus layer. So PeerDAS is the main thing people are talking about now. But even before that, we've been working these past few months on the Petra upgrade, which will also scale the consensus layer blob data. So we can get into any of those, but like high level theme security, and then more recently in the past year or so, scaling, it's been coming up more and more.
You know, I expected the answer, like if I had to guess, was going to be scaling, but I actually really like that. I want to unpack that a little bit more. The idea that security is like this kind of common denominator for all future like properties of Ethereum. Like there are some properties that Ethereum does not have that we want it to have. And so we can like prioritize those. But I really like the illustration of like, well, yes, but first comes security. Yeah. Maybe just like color in that just a little bit more about like why security is so important when it comes to the Alcore devs calls and why everything, all updates to Ethereum has to pass through that security filter first.
So sure, it's like if you think Ethereum should be this robust, durable platform which secures billions and potentially trillions of assets, you want this thing to be safe. And the way that, say, non-crypto handles this is through centralized third parties, right? Mm-hmm. Like your bank has some security control, but if those fail, they'll send like a lawyer to fix it up, right? And you often see these cases like some bank accidentally sends someone like $100 million and then they just revert the transaction. And so, they obviously have checks in place to ensure that they're not sending $100 million to random people all the time. But if and when it happens, there's like this legal system and other ways that they can kind of go off chain to resolve this. On Ethereum, we kind of don't have this luxury, right? Like we have the chain, and when a smart contract is deployed on it, or when someone has some ETH on it, there is no other mechanism by which we could go and change sheets. And this has become more true over time, right? If you look in, blockchain's early histories, Bitcoin obviously had the inflation bug and they had a fork for this. Ethereum had the DAO. And I think what you learn through these experiences is these these events are like extremely contentious for the community, and the bar for them to happen just keeps getting higher and higher and higher. So we need things to be secure because we should assume that we're not going to be able to intervene. And I was looking up the DAO recently, and people like to kind of talk about it, and it's like this very intense part of Ethereum's history. And I think it's kind of less appreciated today just how big of a deal it was. So to put it in perspective, when the DAO hack happened, the DAO had as much ETH as all of the L2s today and the wrapped ETH contract. And that's kind of the scale that it took, to have some sort of social intervention on Ethereum. So if you told me, tomorrow I wake up and like all of the L2s and the wrapped ETH contract are bricked, then like, yeah, potentially we would be considering, some way to solve this. But for anything like below that threshold, we need Ethereum to actually just work. And that is why like it has to be secure. So if we didn't care at all about security, we could get scalability. And there's a lot of other chains who just fork Ethereum's code, 10x the gas limit, lower the slot times, and those chains work, but you can't sync to them. You have to have like manual operations where like, people come in and they like literally restart the chain from time to time. So if you want to avoid all of this, then you need to find ways to scale, but not compromise kind of this ability of the network to keep going.
So would you say, I think there's a large number of reasons as to like why Ethereum upgrades slowly. One is like caution for that security reason. One is like, well, it's a decentralized ecosystem. There's multiple clients. It's just harder to upgrade a multi-component system. But maybe one of the reasons why Ethereum tends to upgrade slowly is because, well, we hold security to the highest degree possible.
Yeah, I think that's true. And I think that's not to say there's no like process improvements or things we could do better. But I think in general, like over Ethereum's entire history, the reason why upgrades are, say, between 6 and 12 months rather than 6 and 12 weeks is because there is like a pretty thorough testing cycle. And I think the other thing is, if you look at all the stuff we did not do, right? Like there's way more EIPs that have been proposed than the ones that have been actually deployed on chain. The common denominator is usually there's something broken from a security perspective about them. And it can often take years to like iterate on a design to get to some version of this idea, this feature that we feel is actually going to be safe on mainnet. And in the current hard fork that's coming up, Pectra, there's this EIP 7702 that helps with account abstraction. And this is like a great example where the first drafts of this EIP probably date from something like 2017, 2018. And it's like over this process of many, many years and rounds of iterations, we've come up with some construction that we feel is safe and also kind of delivers the value of this feature.
Okay, so let's get into the near-term hard forks. There are, but before we do that, let's be one more level meta about it, because I want to talk about the naming convention. I think we did this last time I had you on the show, but I think it's worth tracing over. The next hard fork that is incoming, that is soon TM is Pectra, followed by Fusaka, followed by Glamsterdam. These are not real words. What can you talk about the naming convention for how Ethereum hard forks are named?
So after the merge, we now have two parts to Ethereum. There's the beacon chain, the execution layer. The beacon chain would use star names for their upgrades, and the execution layer uses DevCon city names. So, we still kind of refer to those component parts using that way. So the Pectra hard fork has like the Prague execution layer change and the Electra consensus layer changes, but for users and for the community, it's just like one hard fork that happens at the same time. So we mash them together. So Pectra is just Prague and Electra, Fusaka is Fulu and Osaka, and Glamsterdam is, I forget what the G star is, but then Amsterdam was the city for the first Dev Connect. That's where these names come.
Right. So it's a portmanteau between a city on planet Earth and a star in the galaxy somewhere.
Yeah, correct.
Yeah. Okay, cool. So Pectra is coming up next. And that is the near-term roadmap, near-term hard fork. As a vibe, how would you characterize Pectra? Like, what are the things that Pectra is prioritizing? How is Ethereum going to be changed by Pectra?
So on the consensus layer, the two biggest things are one, the increase of validators maximum balance. This means that we can consolidate validators into a smaller number of them. So when we talk about scaling, a big bottleneck for scaling the consensus layer is how much bandwidth it uses. Ethereum has like a very big validator set. I believe we have over 1 million validators. each of them need to like sign a bunch of messages and then send those messages to all the other validators, which is just like a lot of bandwidth usage. But in practice, even though we have a bunch of 32 ETH denominated validators, many of these are run by the same entities, right? Like Lido, has, say, I think 30, 40 different node operators. So like one of those node operators obviously has way more than 32 ETH. So with the Pectra upgrade, they'll be able to combine this into chunks of up to 2048 ETH. And the reason, or like the value that you get from this is twofold. One, large operators can kind of generously combine their validators together to reduce the bandwidth that they use on the network. And this means more bandwidth for blobs and other kind of scaling stuff, which we'll talk about after. And then the other nice part is if you're a smaller validator, say you have only 32 ETH, today, if you had, say, like 50 ETH, you would have to have like your 32 ETH. You can stake that, but you can't do anything with your other 18 ETH. So with this feature, you'll be able to set up a validator with an arbitrary amount of ETH between 32 and 2048. So for anyone who's like on like the more like solo staker side of the spectrum, it means they can compound the rewards effectively for like any amount up to 2000. And when you get to like 2000 ETH, you can split that into 2000 ETH validators. So there's not really like a ceiling on compounding there. So this feature is really nice because it allows big validators to kind of reduce their bandwidth footprint on the network and then give small validators more compounding. So that's one of the big ones. The other big ones that's coming in parallel to this is...
Before we move on, can we actually just hang out at Maxeb? Because I think it's actually a pretty... I think it's one of my favorite upgrades to Ethereum in a while. And so just to really trace over what you said, right now, before Pectra goes live and before Maxeb is live, Ethereum validators are these discrete 32 ETH chunks. And you can only stake 32 ETH, or you can't stake below that, you can't stake above that. And so if you have 320 Ether, you would need to spin up 10 validators, and you could, in theory, do 10 validators on the same machine, on the same piece of hardware. And then they would be spitting out 10 times as many messages, in theory, as they would really need to, because it's 10 times as many messages going into other people's validators coming back into your machine. And so with Maxeb, we're able to consolidate this like 320 ETH down into one validator that has like 10 times the weight, but still just one machine. Can you just trace over why? I kind of explained it a little bit, but just like how it reduces bandwidth and then what that unlocks for Ethereum.
Yeah, so the reason it reduces bandwidth is assuming we reduce, assuming the validator set stays the same, right? Like say we have 1 million validators today. If we know that like 30% of those are grouped in like much larger entities, take say Coinbase, for example. Coinbase right now, I don't know what's their exact share of the stake, but say they had 20%, it means they have like 200,000 validators, and they're constantly sending messages from like the same servers, or, like a small subset of servers from 200,000 entities. But then with this, they can effectively reduce that by not quite 100x, something like 80x, to go from like, 200,000 validators to like 200,000 divided by 2048, which would be maybe say 1,000.
Must have a much lower number.
Yeah, exactly. Like, about 80x less. And then because of this, it means every one of those like big validators now is only sending one message, but yes, their message has like a higher weight to it. So instead of getting like, 10 pings from 10 different validators, you get one ping from one validator whose weight in terms of attestations and whatnot, you just tax. And like maybe like a very like naive way to think about it is like every validator is currently sending like a message that says like one vote all the time. And then with Maxeb, you can have the same message, but you say 10 votes instead of one vote. And that means that over the internet, like as you're gossiping these messages through all of the peers, you can greatly reduce that number. And for people who maybe don't have an intuition here, it's not like you're sending this message just to one person either, because all of the validators send their messages to many different validators, right? So it's more like you're sending this message like 50 times over or something like that. And then you go from sending this message from every one of those people 50 times over to like still sending it 50 times over, but you're sending one message in each of those things. Does that make sense?
Yes, yeah, totally. Do we have any intuition or any guesses about the reduced bandwidth footprint that Ethereum will have on the internet post this update? Like, do we know how much reduced bandwidth Ethereum will consume as a result of this?
We don't have those yet, in part because like it's hard to estimate. Like you could estimate like if everyone did it perfectly, what would be the max saved. So we'll have to wait and see a bit like, okay, to what extent do Coinbase and other entities consolidate? There are some like moderate risks to consolidation. Like you wouldn't want to consolidate everything on say like a single server, even if you have like, more than 2048 ETH. So I think we're going to want to see like, okay, what the people actually do, what sort of best practices emerge in terms of an institutional use case. But there's clearly some value in consolidation because today, to say, again, take Coinbase as an example, say they have 200,000 validators. They're not running 200,000 independent servers, right? Like maybe they're running, say ballpark, say they were running like 100. Then you could imagine, okay, then there's like some amount of risk that they're already taking where those 100 servers are kind of correlated. And so they can consolidate their validators without necessarily increasing that risk. So that's something we'll have to wait and see. And then the other part of Maxeb that is very good is the smaller stakers get compounding for free, right? Like they start to auto compound their stake. And so what this looks like is, I had 32 ETH when I deposited, and now I have say 34.5 ETH. My vote now counts for 34.5 ETH. And when I'm earning rewards on that 34.5 ETH. And that we'll see kind of instantaneously. So it's kind of nice that this feature works for like both ends of the barbell in a way.
And then I think the last part of this conversation is what this really unlocks for Ethereum with future upgrades. Once you identified bandwidth as a big bottleneck for Ethereum. It's not the only bottleneck, but it's a big one. Once there is reduced bandwidth consumption by the Ethereum protocol at large, how can that help Ethereum? What doors does that unlock for Ethereum in the future when it comes to scaling?
Yeah, so the big reason we want to use bandwidth for in the medium term is to scale the amount of data we can get L2s to use, which we call blobs. So in the Pectra hard fork, we are also going to increase the number of blobs by 50%. So right now, every block can have 3 blobs in them on average, and up to 6 in kind of the worst cases. In Pectra, it's going to be 6 on average, and then up to 9 in the worst cases. So anytime we can kind of shave off some bandwidth usage, it gives us more room in the protocol. If you assume that you're kind of keeping bandwidth requirements constant to like deliver more data to users of Ethereum. And there's another thing we're doing in Petra as well to cut some bandwidth on the execution layer. But you can think of this as like all these kind of small gains that we can compound. We can then directly translate that into more scale for data, which is what ends up powering all the L2s on Ethereum.
Okay, so the bandwidth that we are saving due to Maxeb, we are in the same hard fork in Pectra. We are able to take that bandwidth savings and apply it to bandwidth spendings that we can spend on data availability. Is that correct?
Yeah, basically. And it's a bit optimistic, again, because we don't quite know how much bandwidth we'll save because we haven't seen consolidations. So there were some cases we were concerned about of like worst case scenarios. And to address those, we've made a change on the execution layer that caps the worst, the highest bandwidth block size on the execution layer. So we feel that because we have consolidations coming in and that we have kind of these mitigations for the worst cases on the execution layer, we're able to now increase the blob's security on Ethereum.
Right. And just so I make sure I know this. So when Pectra goes live and we go from 3 blobs a block to 6 blobs a block immediately, we're going to have a doubling in bandwidth just from blob space. But then the savings from Maxeb is actually going to come over time because we will need validators to actually kind of update to this new form factor. And so we don't know how much bandwidth savings we're going to get, and it will take time. And then maybe by the next hard fork, we'll actually be able to say like, oh, we actually maybe even underestimated how much bandwidth savings we're going to get, and then we can add that slack to further blob space in the next hard fork, which is Fusaka. Is that right?
Yeah, that's correct. And then I think to add a bit more context is we knew we had a bit of wiggle room on the bandwidth side before coming into this fork. But again, we had some concerns about like some like worst case scenarios. So by having some wiggle room and patching these like worst case scenarios, it means we can comfortably increase the blob size now. And then yes, to whatever extent we have like more bandwidth in, reserve by the next hard fork, we can still use that to scale Ethereum. But we also have other plans for how to scale Ethereum more efficiently for Fusaka, which we can talk about later.
Yeah. Okay. So we just hit two birds with one stone. We talked about the incoming blob space upgrade. We're getting a doubling in the average blob space going into Pectra. And that's just kind of how it's going to be with all future hard forks, is like we're going to identify that we have some amount of bandwidth slack in the system, and then the number of blobs that we get per block is going to just increase according to what the Alcore devs feels like is safe. So right now we have 3 blobs per block. With Petra, we're getting 6, and then that's just kind of how it works. We're going to get a higher number next time, and it's going to be a downstream like kind of calculation of what we think is safe in terms of bandwidth consumption. Is that right?
That's correct, but there's more we can do to go even beyond that. So one way to think about kind of Ethereum's data availability arc is, before we had these blobs, all we had was call data on Ethereum. Call data is effectively data that you store on Ethereum forever. So it's quite expensive to use. And this is why we came up with these blobs. Blobs are data that is stored on Ethereum but gets deleted after a couple weeks. And because most L2s only need the data there for, like their exit window and fraud proofs, they were kind of overpaying by storing their data on Ethereum forever when they actually only needed this data to be up for a few weeks. So this is how we got kind of the first 100x cost reduction in data for L2s, which is what we have today. And we can keep improving that amount of like ephemeral data. But in terms of just like a qualitative change, we went from data stored forever to data is only stored for a few weeks. The next step we'd like to take is, today, even though this data is only stored for a few weeks, every single node on Ethereum stores it. Where what we'd like to do in the future is move to a world where every node only stores a subset of the data, but then pings other nodes on the network to check with like high probabilistic guarantees that somebody else has the data. And so what we can say is, like, say we have 1 million validators, we can partition so that we have some fixed numbers of copy of that data, and that the validators are always checking, like, okay, is there someone who can prove that they have the data? And this is kind of another qualitative leap where we go from everyone has the data forever to everyone has the data for some amount of time to everyone has a subset of the data for some amount of time and uses cryptography to check that other people have it. And this is the main thing we're working on for the Fusaka upgrade. It's called PeerDAS, but that's kind of the high level idea of going from not only do we have blobs that take up some amount of bandwidth, but if we're able to only download a subset of the blob data, we kind of go from, okay, every node needs all the blobs to every node needs, say, 1/10 of the blobs data, and that gives us effectively 10x increase at the same amount of bandwidth.
So maybe just to make sure I understand that, there's kind of like 2 ways to grow blob space on Ethereum. One is just engineering, which is, I think, what we're doing with Maxeb. We're just engineering more efficient systems out of Ethereum. And then there's like cryptographic step function changes, which is what you're saying with PeerDAS. In addition to that, where, with engineering, we're going to get a doubling. We're going to, with Petra, we're going to go from 3 to 6. Great optimization. Which is exactly what we want. But then with cryptography, we are going from like 1 to 10, or even maybe even something much higher than that. And both are happening in parallel.
Correct. Yeah. And then, so the plan, you can think of like the fork before Pectra actually introduced the blobs, Denkun. So it's like Denkun was kind of like research getting into production. And so we got this like step function change. And then in Pectra, we found like some optimizations and we can kind of improve things. And now we have this other kind of research to prod feature called PeerDAS going into Fusaka. And then even when PeerDAS ships, there'll obviously be a bunch of optimizations we can do to it. So we expect we'll ship PeerDAS with some initial amount of blobs that'll be much higher. Some numbers being discussed or something like going to 48 on average instead of 6, to give you a feel for the order of magnitude or the order of difference. But then once we have, say, 48 running on PeerDAS, there'll probably be a bunch of engineering optimizations we can then do to bring that to some like higher number that's not like, a 5, 10x increase. So I think that's like a good mental model to think about it. Yeah.
Okay, beautiful. All right, I feel like we've actually covered a decent amount of Pectra so far and a little bit beyond. Going back to Pectra, are there any other updates making it into Pectra that are worth highlighting? I know there's often just like a bunch of little things that maybe like are too in the weeds to talk about, but is there anything else, any other stones that we should unturn around Pectra?
I guess one last big one is EIP 7702. So this effectively is the first in-protocol version of account abstraction we'll have on Ethereum. And like I was saying earlier, this is something that's been in the works for a really long time. And the idea is that, let me rephrase this.
Mm-hmm.
The way EIP 7702 works is that you can use any account on Ethereum, so any regular EOA, but you can delegate to an account which adds smart contract functionality to it. So for example, you could have something like, I have my EOA and I want to delegate to something that gives me the equivalent to a safe. And this is kind of neat because it means you can use your existing account with all of your assets and everything there. And you can effectively choose like, oh, this is like the smart wallet I want to run under this account. And you can change this over time. So maybe I have like, my EOA today, I want to delegate it to some sort of safe-esque wallet. So I can do that. But then maybe there's like some other feature that I want to use, or like on another wallet, I want to use, say, auto approvals up to $1,000, right? Like I want to have some smart wallet that just gives me a better UX. I'm able to then use 7702 for on that separate wallet, or to change the delegation on my previous wallet, move to a different sort of smart account. So this is a very nice model because it kind of gives the users the flexibility to choose what they're delegating to revoke that delegation as well, to say like, oh, I don't like this thing anymore. I can go and move back to like not being delegated or delegated to some other feature. And it kind of gives the ecosystem the ability to keep innovating on this, right? Where maybe, we expect there's not going to be like hundreds of these different smart wallets, but say there's like, 5 or 10 that are developed in the next year that are, well audited, well tested and whatnot. And they're great. People use them. But perhaps 2 years from now, someone comes up with like a new idea or a new version. They can just go and, ask people to change their delegation to them. So it's still something that like, kind of allows for innovation in the space and doesn't lock you in to say, oh, you delegated once, you used the safe once and now you're kind of stuck with it. Which is how a lot of smart wallets work today, because effectively, if you have like a safe account deployed, that is like the smart contract, like the address is the safe. So 7702 is more like your EOA has a pointer to a specific type of smart account. And so this is the other thing that'll be going live in Pectra. That's kind of a huge deal.
Yeah, this is relatively new to me. So my understanding, correct me if I'm wrong, is that my EOA, which for listeners who don't know what an EOA is, externally
on address.
Externally owned address. Wow, it has been a while. Externally owned address. And that's just like, if that's your MetaMask, that's your Ledger, that's your Rabby wallet. It just means that it's an account that is owned by something external, as in your private keys is, I think, what is being referenced externally. And then in contrast to that is a smart contract wallet, which is the owner of a smart contract wallet is going to be an EOA, not itself. Okay, so with this, what you were describing, it kind of sounds like there's going to be some very useful addresses out there with these bundle of features that I'm going to be able to point my EOA to and basically have those features be like absorbed into my EOA, or like I'm like, for some reason I'm getting like having this mental model of like some like
you can think of it as almost like a plugin for your EOA.
A plugin. That's what I needed.
Yes.
And so I just point my EOA at some smart wallet out there that has been deemed useful by the community, and all of a sudden I have those features that correlate to my EOA. Is that right?
Correct. And then you're also able to change that in the future, which is the other important part. Because today you could just set up like a Gnosis safe, and Gnosis safes are great, but you can't change your Gnosis safe to like something else, right? It's fundamentally a Gnosis safe. Whereas in this model, you're able to say my EOA has like plugin A, and I don't like plugin A anymore. I want to go to plugin B, and you can do this and still keep the same address and still keep the same private key that secures the EOA.
So it sounds like just a hybrid benefit model of just like, there are something properties about my EOA that I like, but it doesn't have any smart contract features. And this kind of sounds like it's trying to thread the needle of being the best of both worlds.
Yeah, correct. And this is kind of why it took so long to get to these types of solutions, where it kind of blends a lot of what smart wallet developers want with kind of the practical realities of, okay, users have EOAs today. How do we, minimize the migration costs? And also, how do we do this in like a relatively safe way? And so one example on like the safety side was, should we allow this when you delegate to a plugin, should it happen just on Ethereum or across all of chains? And we felt like it should happen on Ethereum. And that if you're delegating to another chain, you should have to like click the button twice. This is it's worse on the UX level in a way, but it also means that say you're using some random L2 and they have some sketchy like delegation wallet and you happen to delegate to it, you don't get all your assets drained from every chain forever. Or imagine, like some other ecosystem copies Ethereum, which often happens, and they decide that like some stuff is safe that the Ethereum community doesn't think is safe. If you're using your same address on say chain A and chain B, delegating to something bad on chain B won't automatically mean you lose all your money on chain A. So this is kind of one of these examples where like, okay, thinking through the actual security implications was really important. And I think in this case, we've landed on a really nice compromise between giving a lot of value and like functionality to users, while also making sure that there's like some level of security in the system.
Is this update something like a foot in the door for future improvements on the Ethereum smart contract wallet like landscape? Or do you think this is something closer to, and we are done here, let's wrap a bow on this and call this good?
I think we'll see more. I think there's a lot around account abstraction that's, not part of this. So at the very least, the entire arc around not having ETH to pay for gas and, having a wallet that manages that is not part of this. Obviously, if you're using an EOA, it assumes there's ETH in the balance. The other part around the account abstraction is, okay, what if you want to actually change your private key on an account? That also is like completely out of scope from this. So I think 7702 effectively gives us like a very practical feature to address most user use cases, which is like, I want to delegate to some smart account. I want to do auto approvals. I want to have like some social recovery. So you can address all of these. It doesn't solve everything. It's not like some silver bullet. But we felt it was better to ship something useful short term than to try and like come up with the perfect solution and wait for another 5 years. Especially given that people have been wanting something like this for probably already 5 years.
Yeah. And I think one of the parties of people that have wanted something like this the most are layer 2s, because layer 2s have had to roll their own code when it comes to building smart contract wallets into their chains. Because we all understand that the smart contract wallets are very powerful, very beneficial. We're eventually all going to have them. Layer 2s who have been faster to move than the Ethereum layer 1 have just beat Ethereum to the punch and just rolled their own code and built their own smart contract wallet straight into their chain. But as a result of that, just like the layer 2 fragmentation problem, is that they have all built their own solution and now there's no standard. So now the Ethereum layer 1 has some semblance of some standard. How does this conversation carry into layer 2s? How does this impact like layer 2 roadmaps when it comes to smart contract wallets?
I think, it helps to say there's like a standard there. If there's still a lot to unpack in terms of standardizing account abstraction on layer 2s. I do think like, all these questions around, okay, gas payments or, what is like the default flow you onboard people on, or just interoperability across different L2s are things we will continue to spend time on. But I think for layer 1 broadly, and then for layer 2s as a default, 7702 is like a really good practical step. But yes, you will keep hearing about account abstraction debates for the foreseeable future.
I have heard about smart account abstraction debates since I have been in Ethereum, since like 2017.
Right. People have been working on this for a really long time.
Okay, so I think, Tim, that wraps Pectra more or less. Again, there are many other EIPs that are getting into Ethereum in Pectra, but many of them are small. This kind of is how hard forks work. Are those all the big ones that are worth discussing?
Yeah, I think, for all practical purposes, yes. There's about 10 EIPs, I believe, in Petra, so there's plenty more there. If you're a smart contract dev, there's things like the BLS precompile that are coming in. If you're a validator, there's also a bunch of other tweaks around the deposit queue and using execution layer withdrawal credentials. So there's definitely more to explore. I wrote an article about it, and there's, I believe, going to be a section on eth.org about the upgrade as well. So if people want to go deep, there's a lot to go into, but at a high level, Maxeb, increasing the blobs, and 7702 are the biggest kind of new features coming in.
Let's talk about timeline, because we are currently in the testnet phase of Pectra. So some of Ethereum's testnets are being enabled with Pectra enabled. They're getting Pectra'd as we speak. Where are we in the timeline for Pectra making its way all the way to the Ethereum layer 1? Like how soon can we expect Pectra?
Yeah. So if you follow testnets, you'll notice that there's some
issues.
So We ran into issues on testnet mostly due to different configurations between testnets and the Ethereum mainnet. And the reason we have these is, in short, because there's no incentive in proof of stake to run a testnet. So we kind of have to come up with these ways like, okay, how are we going to test stuff if no one wants to run a node? So we have two testnets right now, Sepolia and Haleshki. Sepolia has a whitelisted validator set. So because we want it to be stable, we said only like client teams, infra teams, and like, whoever else is like a professional operator that wants to do this can run it. So to actually run a Sepolia validator, you need like a special ERC20 token, which means the deposit contract on Sepolia was different. And so we ran into some bug because of like how the deposit contract on Sepolia was structured relative to mainnet. Before that, though, we ran into another issue on Haleshki, where Haleshki has an open validator set, but we wanted the ability to like mint some amount of ETH and kind of configure the network a different way, because on Gordy, we ran into all these issues around like not enough testnet ETH going around. So we fixed all of this, but then when deploying the Haleshki testnet, because of some changes, the deposit contract address was different. And we also ran into some bugs because some clients like effectively assumed that it was the same. And so because of this, like the testing process has been a bit like curveballed with like relatively minor configuration issues that ended up kind of delaying things. And then because they affect the validator set, especially on Haleshki, they ended up kind of making it much harder for validators, especially staking pools and people with more complex setups, to test the entire lifecycle on the network. So to address this, we actually launched a new testnet today called Hoodie. So the idea is to have this new testnet from scratch, have an open validator set that people can use. And this is kind of our last step towards testing Petra before we go to mainnet. And the idea is that we not only want core devs to test Petra, which we've been doing and can still do on Sepolia and Haleshki, but we want people like, say, Lido and Rocket Pool to test this, especially because there's so many of these features like Maxeb, but also some other features around how exits and withdrawals are processed, that it's really important for them to get right before this goes live on mainnet. So testnet launch today. The Pectra hard fork is happening on this testnet next Wednesday, which is March 26th for people listening. After that, we expect it'll take a few weeks for, staking pools and other people to just test their entire infrastructure on the network. They have to go and redeploy everything and make sure that it all works. And for a lot of these staking pool projects, it's not just a set of smart contracts, right? Because they run all these validators, they have oracles. So it's a fairly complex setup. So that is kind of the last part of testing that we want to make sure things work well for them before we move to mainnet. If we found something that, broke how staking pools manage exits or something like that, we'd obviously want to reconsider when we move to mainnet. So assuming all of this works smoothly, the earliest date we said we would fork mainnet was 30 days after Hoodie has this Pectra fork activated. So from March 26th, that would be late April. It's possible that we have a few weeks after that if there's like some testing to be done, or we realize there's like some minor issue to fix. But I think we'd be looking, if things go relatively well, sometime around May for Pectra.
Okay, so May is the happy case for.
I'd say it's like the base case, like
base case.
Maybe we find some minor issues or stuff like that, but if we find some major issues, something completely wrong, it would go beyond that. I do think at this point Petra's been tested quite thoroughly. I don't want to bet on this. Like, I feel like if I say, we're all good, then we will find something else as soon as I wrap up this call. But I think base case is like May's reasonable timeline.
Imagine a world where your day-to-day banking runs on a blockchain. That's exactly what MANTLE is building, powered by a $4 billion treasury and poised to become the largest sustainable on-chain financial hub. As part of their 2025 expansion, MANTLE is introducing 3 new core innovation pillars that bridge traditional finance with decentralized technology. First is their enhanced indexed fund. Aiming for $1 billion in AUM by Q1, it provides optimized exposure to Bitcoin, ETH, Solana, and USC, complete with built-in yield opportunities. Next, MANTLE Banking promises to revolutionize revolutionize global value transfer through seamless blockchain-powered banking services, bridging crypto into your daily life. Finally, MANTLE X blends AI with DeFi to deliver an intelligent, user-friendly experience for everyone. And the best part is that this is all in addition to their already launched products like MANTLE Network, METH, and FBTC. Ready to step into the future of finance? Follow MANTLE on X at @mantle_official and join the on-chain revolution today. CELO is transitioning from a mobile-first, EVM-compatible Layer 1 blockchain to a high-performance Ethereum Layer 2 built on OP Stack with EigenDA and one-block finality. All happening soon with a hard fork. With over 600 million total transactions, 12 million weekly transactions, and 750,000 daily active users, CELO's meteoric rise would place it among one of the top Layer 2s, built for the real world and optimized for fast, low-cost global payments. As the home of the stablecoins, CELO hosts 13 native stablecoins across 7 different currencies, including native USDT on Opera MiniPay, and with over 4 million users in Africa alone. In November, stablecoin volumes hit $6.8 billion, made for seamless on-chain FX trading. Plus, users can pay gas with ERC20 tokens like USDT and USDC and send crypto to phone numbers in seconds. But why should you care about CELO's transition to a Layer 2? Layer 2s unify Ethereum. L1s fragment it. By becoming a Layer 2, CELO leads the way for other EVM-compatible Layer 1s to follow. Follow CELO on X and witness the great CELO happening, where CELO cuts its inflation in half as it enters its Layer 2 era and continuing its environmental leadership. You may have already heard about INFINEX. INFINEX has, in my opinion, the nicest cross-chain swap and bridge feature that you will find anywhere. It is called Swidge, Swap and Bridge, and we're gonna show you what it looks like. First, we're gonna log into my INFINEX account with a passkey. Now, there's no seed phrases in INFINEX. This is just a one-click setup with biometric passkeys. But in addition to that, my INFINEX account is fully non-custodial. So bam, I just logged in. It was 2 clicks and I'm already into my INFINEX account. So let's go make a swidge. I'm gonna go swidge my USDC that is on base, and I'm gonna buy Berachain, which is a completely different chain. So we're gonna swidge this. I'm gonna press that button, and then INFINEX is gonna execute this order, this cross-chain order for me, and now it is done. But actually, I'm not really feeling bearish anymore, so I'm gonna go from Bera to Penguins. I'm gonna buy a Penguin on Solana, so I'm going from the Berachain to Solana. See, no transaction signing, no gas to worry about. You just swidge across whatever chain that you want with INFINEX. That was so easy. Go check out INFINEX and try your first swidge today. Okay, so May is the base case, and then after Pectra is Fusaka, Fusaka, and then after that is Glamsterdam. Yep. Just like, I know timelines, as soon as we get any further out than one hard fork, just starts to become incredibly hazy, and we don't really want to like set any expectations. But understanding that, can we just like draw a like hazy cloud of timelines for Fusaka and Glamsterdam?
So for Fusaka, I think there's a couple of things that are really important. One is we've been working on Fusaka for quite a long time now. So the 2 main features for Fusaka are PeerDAS, which we talked about a bit earlier, then EOF, which is a big overhaul of the EVM. Both of those things we've been working on in parallel to Pectra for like over a year now. So we have DevNets, they're running. The specs aren't completely frozen, but we have pretty stable specs that are being iterated on and kind of getting the finishing touches, which is very good because it means we're coming into this next hard fork and we have the bulk of the code for the hard fork after for Fusaka already written. I think there's a very strong desire across the entire community, both core devs and everyone else, to see a larger blob increase before the end of 2025. So that's been the rough target for Fusaka. So saying, like we want to ship PeerDAS, we want it to happen this year. I think what this means is if there's any other feature in this fork that say were to delay PeerDAS, we would just remove it. So we'll probably keep the scope for Fusaka relatively small. We want to finalize the scope for Fusaka we want to finalize the scope for Fusaka around April this month. So the hope is that, when Pectra has gone live on mainnet, we already know everything that's included and nothing else is being considered. But then even for those other things, if we find some weird issue or bug or delay, we would probably err towards removing them to make sure that PeerDAS can ship in 2025. And then I think the risk there is if there's something unexpected with PeerDAS itself, obviously PeerDAS is the most important thing to ship. We will do everything we can to ship it this year, but this is why the reason the hard fork timing conversation is hard is because so many of these things have like a heavy R&D component to them. So, if there's like an unknown, it can be hard to predict like, we didn't know that this issue would show up because this thing did not exist 3 months ago. I think the fact that we've been working on it for over a year means there's a reduced chance of that. But yeah, you can't completely write off the chance that like, okay, we move forward with pure DAS, we see that there is this thing to fix with it, and like the quickest path to scale in Ethereum is still to fix this thing. So I'd say everyone's trying hard for 2025. It's unlikely anything else than pure DAS would be like the cause of a delay. But if something happened with pure DAS or some like big unexpected twist, obviously that can always delay things.
I want to read a tweet from Vitalik that I'll also share on screen here. He tweeted out, this is on March 1st, so about a little over 2 weeks ago. He says, for 2025, we need Fusaka on the layer 1 with pure DAS, ideally with 48 blob target, 48 blobs per block. And then he follows up saying, let's aim to get a Fusaka testnet with these blob parameters running the day after Pectra goes live. Now, I don't know, Tim, if there was any previously established like expectation on blob count for Fusaka prior to this, but this was, in my interpretation, something like a doubling, 2.5x more aggressive blobs per block than I expected to have by the end of this year. Maybe you could check me on that. And then also just kind of like fill us in on what the reaction was around the Alcore devs space around this tweet.
Yeah, I think people broadly agree with this. Maybe some of the caveats are one, whether the DevNet goes live the day after Pectra goes live or not. Like, again, we already have a pure DAS DevNet up. So we are, getting close to this. And I think at a high level, the thing that's still somewhat undecided is the best way to test this to start with the highest possible blob count, say like 4872, and then kind of work backwards from there? Or should we try to like run pure DAS with, say, the same number of blobs, make sure that works, and then ramp up and see what breaks? I see the value in both approaches. So like we haven't quite made a call yet. So you could imagine something where we decide to test pure DAS with like a lower number of blobs, and we're like doing, I don't know, say 1836 or whatever, and that goes well, and then we try 2440, and then that breaks, and we feel pretty confident in 1836. It might be the better move to just ship this, and then in the fork after that, go from like 18 to 42 or whatever. So I wouldn't necessarily commit on a specific number. I think everyone agrees that we want to get there. But it's really hard to know, like, okay, is there some weird point where things break between what we have now and that number? And we should figure that out before we ship it. One other idea we've been considering is maybe we should ship pure DAS if we're like pretty confident that we can reach this high number, but we still want to make sure. We could ship pure DAS with kind of like an escalator increasing blob count, where we say, okay, when the fork goes live, maybe there's like actually not even a blob increase, but then 2 weeks after that, it goes, from 6 to 8, and then 2 weeks after that, from 8 to 10 or something like that. And this could be kind of nice because it would maybe let us make sure that at every step of the way, things are smooth. And then if there is like some major issue at some point, you kind of have enough time to intervene. So the exact rollout to get to that number is still being discussed, but I think broadly people agree we should have this in 2025. We should go for like a fairly aggressive number. But we want to make sure that, we don't just overshoot and then miss out on like some, 2-3x improvement over the status quo because we're trying to go for closer to 10x.
Mm-hmm. Understanding that the Alcore devs community, group of people are like cautious by default. Is there, I'm still getting a hint, some like rumblings that there's just more appetite for aggressive numbers, aggressive scaling numbers. Maybe you can kind of comment on that vibe, like loosely, like what is the appetite for aggressive scaling numbers or just like more aggressive shipping around the Alcore devs community?
There's definitely like a renewed, I don't know, interest, or say like accelerating. That said, we have, the blobs have been live for like a year, right? Like a year ago, we shipped like this reduction from call data to blobs. This year we'll ship hopefully pure DAS as well as kind of this increase with Fusaka. So I think it's true that it's always been kind of a priority to scale. Maybe the thing that's changed recently is realizing that this should be not only the only priority, but like part of a much smaller subset of priorities. I feel like the perception or the thing that kind of gets Alcore devs is not just like people don't care about scaling, but they care about scaling and 19 other things. And then being able to focus and saying like, okay, scaling is the only thing, or like one of the few things that actually matters in the short term, and we should double down on that. I think that sort of like vibe shift is happened. Definitely on the consensus layer. I think on the execution layer as well, there's been more thinking about like what is the right role and what is the right thing to optimize for. So now that we have, L2s in production, I think everything around the MEV space as well has kind of settled a bit, where for the past couple of years, it wasn't quite clear what, proposer builder separation would look like, what would the bottlenecks be. Now it at least feels like we have some good understanding of what is like the topology of the execution layer. And we can actually identify bottlenecks and be like, okay, this is the thing that's preventing scale there, and this is the thing that's preventing scale there. And start addressing those. I think historically, it's been hard to do this because there's many moving parts, and the execution layer has less of a like clear lever or clear thing to tweak. We have the gas limit, but the gas limit is kind of an aggregation of all these different things, right? Like all the opcodes, all the state growth and all of that. And now I think we understand much better, like, okay, these are all the inputs that go into it. And these are the things that will break at these levels. And so we can kind of prioritize solving them. But yeah, renewed focus, I think would be the right way to frame it. And that said, it's still like an open process, right? There's still people who disagree with this. There's still like different perspectives. And I think this is something we want to be cautious of not losing, where, Ethereum is very valuable because of this like plurality of thoughts and of contributors. So while you want to like focus people, if you overdo that, then it's easy to just have everyone kind of feel excluded, and, you end up being like a very small circle, and everybody else is left.
Okay, so we've pinned down Pectra. We're in the process of pinning down Fusaka. Fusaka is mostly pure DAS and increased blob counts, but then also this thing called EOF, which I have just learned as of this morning is called Ethereum Object Format. I don't know what that is. Maybe you could enlighten me. What is EOF, and why are people so excited about it? Because when I asked Twitter about like what I should ask you on this episode, Tim, EOF was a pretty common thing that was brought up by people, and I don't know what the hell it is. So please inform me.
Okay, so the best like non-virtual machine expert analogy I've heard is Ethereum's virtual machine is kind of like a 1950s computer, and EOF makes it like a 1990s computer. So
still not 2020s.
No, we are like literal decades, and I think this is correct because computers are very hard, they're complex, and Ethereum needs to be super secure. So it's reasonable to say like you want to have a limited feature set. Like we don't want to do everything that modern computers do on the Ethereum virtual machine because we keep finding bugs in those. So there's a lot of debate around EOF, but I think like at a very high level, this is kind of the gist is, do you think like a 1950s style VM is sufficient and like minimal enough and we can just build everything else on top? Or do you think we should actually take the time to improve it to go to something like the 1990s? Which is not to say we bring it to like the absolute cutting edge of computer science, but it's like we add a bunch of things that are kind of pretty table stakes that the EVM lacks. And some like, pretty high level parts of this is just like separating code and data in the EVM. So right now, when you have like a smart contract, the code and the data that's stored in that code can be kind of all mixed together. And for a bunch of toolings, it's much easier if you're able to say, okay, like this is the code and this is the data that goes into the code. And, current EVM contracts do not have things like that. There's a bunch of just like specific opcodes that, we lack that make it, just writing compilers and writing programming languages on top of the EVM easier. The other thing as well with EOF is there's a bunch of things that we would like to ban in the EVM for different reasons that you sort of can't do on the main EVM because contracts use them. But now with EOF, we kind of get this like fresh start where we're able to say, okay, like now you can't do those things anymore in these types of contracts. And maybe to zoom out a little bit, like the way EOF works is it's effectively like a versioned type of the EVM. So you'd see like if a smart contract has an address that starts with these specific things, it's an EOF contract. And if not, then it's not one. And that's kind of the high level idea. It's just saying like, okay, for like these new types of contracts, which are opt-in, we're not like forcing anybody or like deleting any old contracts. We just have like more functionality. We have like some better kind of data management of what's in the contracts. And we kind of remove some stuff that we feel is just like not super valuable and kind of problematic to a lot of the longer term Ethereum roadmap items.
So is this mainly an upgrade to just the developer experience for people who are writing Solidity, or like who really whose life is enhanced the most here?
Yes, and it would be like one level underneath that almost. It's like an upgrade for Solidity and other languages on top of it, right? Like you can think of the Solidity is constrained by what the EVM itself can do.
Okay.
And so by improving what the EVM does or how it is like structuring the work that it does, then we can improve the experience of the people who write compilers and write programming languages. And then also, I think, again, back to security, anyone who's actually looking and trying to analyze what contracts actually do, and especially in edge cases like auditing and stuff like that, EOF also helps with some of this.
Okay. I'm finding it hard to analogize about this, but I think I get it. There's just like a very low level structure of how the EVM works, and we're just upgrading it. It's just getting better. It's going from a Toyota Camry to, which is something very dependable and very standard, but maybe kind of clunky, to something like a Volvo, which is also very dependable, but a little bit more polished.
Yeah. And I do think the 1990s like example, I don't know if it's perfectly accurate. I'm not like a VM expert, but I think it gives a rough sense of the level of like complexity as well. So a lot of the objections to EOF around complexity and whatnot, and while it is true it's a big upgrade, it's also not saying like, okay, we are going to take like the absolute cutting edge, of like how computers are built today, like say, I don't know what Apple, whatever they do and like their chips, whatnot, like, and then do that. Like we will, like we're still, in relatively basic territory.
Okay, great. So that's Petra, that's Fusaka. Is there anything else left in Fusaka worth highlighting?
So we haven't finalized the scope for Fusaka, but I think, like I was saying earlier, one thing that's clear to everyone is we want Pectra and we want PeerDAS to ship as soon as possible. So a few of the client teams have already signaled what they'd like to see in the fork, and generally the sentiment is that PeerDAS and EOF should be the only two big things. We should maybe include like some select amount of small things, especially if they're like some security related or like, very like easy low hanging fruits, but we should not try to do too much. And actually Pectra used to have PeerDAS and EOF as part of the single fork. And last summer we realized that was way too much and we decided to cut it. So you can think of Fusaka as like the two big things, EOF and PeerDAS, that were originally in Pectra, but felt like they warranted their own fork. And approaching it with that mindset is probably the right approach, saying like, okay, we already had way too much stuff. Now we like ship the first half. Let's just ship the second half, maybe, add a couple small tweaks, but not try to like do the same mistake again where, instead of having like EOF and PeerDAS be the ones that are moved out, we add a bunch of stuff and realize 6 months later that it's too much. Those two are already pretty big changes. So we should stay close to that if we can.
And then after these two comes Glamsterdam. My intuition is that Glamsterdam, we know the name, but it's just so loose and nebulous about what's actually going to go in it. It doesn't really have an identity yet. It's just kind of this placeholder name that we know is coming, that we're going to deposit things that we want into it at a later date and time. Is that kind of the vibe?
Yeah, that's correct. And one thing that we're thinking through at the Alcore devs level now is we've gotten better at parallelizing working on the forks over time. So like now, what's coming in Fusaka, we've been working on for like the past year. And one sort of experiment we'd like to move towards is, okay, if in the next month or two, we have the scope for Fusaka completely finalized, can we already start planning Glamsterdam so that, a few months after that, we know exactly what's in Glamsterdam and teams can start working on it. And then, we start looking at the next thing. And there's a limit on this because a lot of the times, like, you want the same people to look at it all, right? Like you can't completely replace people and just have, say, like group A decide what's in the fork and group B implement it, because group B will probably have like high context around what should go in and the risks there. But I think just getting better at parallelizing like the planning of the fork and the implementation, so that as soon as we're done with one, we have prototypes for the next one and we're kind of ready to make it the main thing. Hopefully we can we can do that so that, Glamsterdam is set up in the next few months in terms of scope. And we're starting to talk about what's next while we start to prototype Glamsterdam and ship Fusaka.
Okay, and this kind of just all goes back to a related conversation about just like Ethereum Alcore devs being just more aggressive and ambitious about upgrades. Maybe not ambitious, but just learning to really process make processes for all of these things and learning how can we really, where can we take up slack in the development system? Because Ethereum's greatest strengths is that it's decentralized, it's rough consensus, but that produces its like weak underbelly, which is it's slow. It's slow, and we have these like centralized smaller competitors that are really taking advantage of this, and so like learning to have faster upgrade cadences. That energy is coming out of like this angst in the Ethereum community of like, Ethereum just goes so slow. Why does it have to go so slow? And well, there's very good reasons why it has to go so slow, but it sounds like the Alcore devs calls they are finding some slack in the upgrade system that they are taking out of just via operations and process. Is that right?
Yeah, and I think you can think of two causes to slowness. One is like process and operations, and we should obviously remove all of that slack if we can. And the other one is just due to like R&D being hard, right? Like, so again, to take pure DAS as an example, or even something that already happened, take like the merge. When we started working on the merge, like we knew this was the priority and we made it the priority number one. But as you work on it, you find new stuff, you find new issues. You should still keep working on the merge, right? It's still the most important thing. So I think a lot of the time, like there's all these proposals saying like we should hard fork every 6 months or every quarter or whatever. This sounds good in theory, but imagine we were doing this, say, for the merge, and it's like, okay, we mixed this 6 months deadline. Do we just like ship a bunch of random, less useful stuff?
Random shit, yeah.
Like, it's like, obviously we should not. Like, obviously it's still the highest important priority to ship the merge. And so, if it's going to take an extra 6 months because there's something fundamentally hard about the merge, we should still be willing to pay that cost. And sometimes this can stop being true. Like maybe like the merge was probably the most consequential upgrade, but you could imagine, there's something else we work on that we think is the highest priority. And then we realize it's going to take an extra year. And the fact that it takes an extra year might mean it's no longer the first priority. But I think that's like a different type of slowness from saying like, okay, are we spending 6 months like waiting around to figure out what to do? And that latter type, we should obviously just, get better at that. And I think we have over the past couple of years, and a lot of it has happened fairly informally. So I think now we're at the spot where we can start to say like, okay, this is how the process actually should work. And we have all these components. We're like, we're already prototyping these hard forks, one after the other. We already have like this loose intuition that we should know what comes next. So let's just like make that a real commitment and say like, okay, by this date, we finalize the scope. By this date, we expect to start prototyping. And if there is like some hard R&D or engineering issue, like obviously we'll take the time it needs to fix it, but it's not like the process slowing down the engineering. And so I think like, we are trending towards that, and hopefully we'll get there at that still in the next year.
So Tim, you probably have, out of anyone, the most context for how Alcore devs works and how the Ethereum upgrade process works, or just Ethereum broadly. What's the most frustrating FUD or misconception you would like to clear up? Since if you're the high context individual around your little domain, and then there's 10,000 low context individuals tweeting bullshit on Twitter, what's the most annoying thing that you hear that you would like to address?
So I think one thing that always is weird is when people talk about things being delayed before there's been like a date set to them. and this is kind of part of my like, engineering unknowns process. And I've struggled to find the right way to deal with this, because everyone wants like to know when the upgrade is going to happen. Like Fusaka, like I just said, Petra will happen sometime in May. And this is like this is like my current base case based on like everything I've seen and I know, but like it's not scheduled for May, right? Like we don't have like a date that says like it's May 18th or it's May 7th or it's May 23rd or whatever. And so there is a point where like we do schedule that thing and say it's like a month out. And then it is like actually a delay to say like, okay, it was scheduled for May 13th and we found a bug and it's now May 28th. But I think like, the hardest part is figuring out how do we talk about things when they're still in the uncertainty level, while not falling either into like, oh, we say like Fusaka is going to ship, on October 15th, and then it doesn't. But then the alternative is saying like, okay, it'll ship when it's ready and it ships in 2027 and Ethereum's become irrelevant. So I think on both sides, I kind of feel this pressure of like, what is the right level of granularity to give to stuff based on the current level of uncertainty? And and I don't think we found like the right way to communicate that, to say like, okay, this is like a 6 out of 10 certain for like this window, because there's like these like unknown unknowns. And if if like I could somehow fix that, I think it would make a lot of the like perception issues much better.
One thing we haven't talked much going through some of these hard forks, Petra, Fusaka, Glamsterdam, is scaling the layer one. So where does the conversation around scaling the layer one rank in priority? What does that conversation look like? How does that conversation fit into the future of Ethereum?
So I guess by scaling the layer one, this means scaling the execution layer, right?
Yeah, scaling the execution layer between just gas throughput and or block time increases or decreases of block time.
Yeah. So I think this is something that's been like getting more and more attention. Again, there's like bad ways to do this and they have like security issues. But what I was saying earlier is now I think we understand a bit better what some of those bottlenecks are and what the ecosystem looks like. So there is a renewed interest in it and at least a better understanding of, okay, for example, state growth was one of the things that over time like stopped us from scaling the layer one. But then Paradigm did a bunch of research last year and realized like it's maybe not as much of an issue in the short term at up to some levels than we thought it would be. So like understanding like, okay, actually history growth is like a bigger bottleneck on node in the short term. State growth will become a bottleneck on nodes, in the medium term. And then, we have these other bottlenecks at different places. That feels like it's improved a lot in the past year, and will continue to do so. And this is kind of the fundamental challenge here is, we have the gas limit, like we can say we just increase the gas limit, and that is kind of our very like coarse lever, but it would be good to understand like what is exactly the effect of doing that. For example, one other effort that's been happening recently is thinking about, can we reprice opcodes in Ethereum to make a bunch of stuff cheaper because it's currently overpriced, so that, we can keep the gas limit the same, but there's a bunch of stuff where we can increase the amount of those operations in a block, for a fixed size. So yeah, maybe like a way to frame it is on the consensus layer side, we have like a very clear North Star, just like, okay, how do we like scale the blobs? On the execution layer side, the North Star is clear, the gas limits, but the mechanisms or like the inputs to it are just like much more complex than on the consensus layer side, because the consensus layer, you just have like some amount of data and you're trying to figure out how to send it, shard it, distribute it efficiently. So yes, it is. I think it is like important to scale the L1 and people are working on it, but there's less of a clear understanding of like, okay, this is the actual short-term practical thing. We kind of have 10, different things that people are working on, and hopefully those kind of compound together.
Mm-hmm. The conversation of scaling the layer one is just so multivariate, and there's many different inputs, and that makes it complex and harder to like really optimize. Whereas with scaling blob space, it's like pure DAS and blob targets.
And again, like it's not like an impossible thing on L1, but I think we're now in a better spot to like actually start to tune those knobs than we were a couple of years ago. And to give you an example, like just the idea of like, okay, where does the block get built, right? Is something that's changed a lot, because now most blocks get built through like MEV. And one of the things that's kind of a bottleneck on this is like, when should a block be verified? And the way that like, naively block verification works, it's just like, you kind of build this block, you verify it all within the current slot, and then you're good. But now, because of MEV, people want to wait until the last possible second to actually build a block. So we have kind of less time for verification, which is fine now, but if we scale the gas limit, becomes a problem. So if we know that we have like high resource builders that can build these blocks very efficiently, should we just delay when we actually verify them and say, okay, you build a block for slot 1, it gets verified in slot 2. And that's probably a way that we can, leverage the way the ecosystem has like been set up to scale the L1, but it's something that wasn't as obvious, say, 2 years ago. And that's just like one random example, but it's all these types of things where, okay, now that we actually understand things better and the equilibriums are a bit like better set, we can have better intuitions for this. And hopefully this means we will scale the L1 as well. But I think there's more research work, like applied research work, to be done there.
Mm-hmm. One last conversation, Tim, before I let you go, just the conversation around interoperability and fragmentation of layer twos. How does any part of that conversation actually in scope for Alcore devs? And if so, what is in scope for the interop conversation for Alcore devs calls? Because I think that's mostly an ecosystem standards thing, so it's outside of Alcore devs calls. But is there to what point is that actually a conversation that is talked about in Alcore devs?
So there are some cool protocol things we could do. The challenge is they are a lot of work and they make a lot of like complex assumptions. So they will take years to ship. So yes, like this is something we think about, but it's not going to happen in like the next 6 months. So I think if you're looking in the short term, then going all out on like what can you do at the application layer in terms of standards is the way to go. But longer term, like, yeah, Justin has this idea around, native rollups, right? You can imagine this being a direction we go in where we say, okay, there's like a common precompile on Ethereum that rollups use, and that because we know they're all using this, they can interoperate better and get kind of, L1 guarantees around this. The challenge is this is like an extremely complex piece of code that, is custom to every rollup now. So we need to figure out like, okay, what is the right abstraction to have on L1? How do we test this? Rollups have very different like performance and security guarantees than L1. They're kind of architected in like a different way. And so it is going to be years of work to figure out what is the right set of abstraction that kind of works for rollups, works for L1. But yeah, I believe pretty strongly we should do this. Like, I think if you think of Ethereum L1 as kind of like a utility provider for like rollups, like we need better plumbing and infrastructure and stuff there. And we should also be willing to say like, okay, after consulting with everything that existed and like, we think this is the right approach and, nudging existing rollups to migrate to that. Like I'm pretty bearish on the idea of like Ethereum creating like an L1 enshrined rollup or something like this to like go and compete with what exists. But it should be fine to say, hey, these are like some standards, say contracts on Ethereum or protocol features that give you interop features that give you security, but you're going to have to migrate to adopt them. And obviously the migration should be possible for rollups. Like it shouldn't be something that says like, oh, you have to completely abandon your project and start a new rollup. But yeah, that entire process of just designing the right thing, getting people to adopt it, but not is not going to happen within 6 months. So in the short term, I'm very bullish on just app level and wallet level standardization.
Tim, this has been super informative. I've learned quite a lot. So thank you for coming on and just helping me run through some of these things. Is there anything that I haven't asked, any like stone I haven't unturned about any of the near-term hard forks in Ethereum or anything adjacent to that?
No, I think we covered a lot. Cool. Yeah, can't think of anything right now.
All right, well, one last thing before I let you go is Summer of Protocols. This is something that we did on Bankless, actually, the first Summer of Protocols. If maybe listeners missed those episodes, maybe you could talk to them about what Summer of Protocols is, because I'm reading your tweet here. Summer of Protocols is back for 2025. Just give the listeners a little bit of context of what's going on here.
Yeah, so the idea with Summer of Protocols is that when I was working on Ethereum a couple of years ago, I realized there's not a lot of analogs for the thing I work on, right? Like if you're like a software engineer and you think about like writing good software, there's a lot of ways and like frameworks about how do you write good software. If you're like starting a company, there's a lot of like frameworks for how do you run a startup. There's not much out there in terms of how to work with protocols. And this comes up often when people talk about Ethereum, right? They say like, oh, Ethereum's like this tech platform, or ETH is money, or ETH is like a world computer. And so there's like all these different aspects that represent part of it, but are not kind of a full picture. So in 2023, when we launched this, we wanted to figure out, can we actually understand protocols better? And so we funded a bunch of researchers in many different domains to study protocols and try to see, okay, do they have some common like learnings? And it turns out that they did. Last year, we wanted to test, like, does this actually work in production? So we funded a bunch of people to like improve protocols in different domains. We had some people working on like cryptography protocols, some people working on like wildfire management, some people working on plurality voting, and figure out like, okay, are there like more like applied things of how you do your work with protocols that we can generalize? And we also found there was a bunch of stuff. Now in 2025, we feel like we have like all this knowledge, but it's very poorly organized. It's a bit chaotic. And so we want to try and make it understandable for the world. So what we're funding is a bunch of teachers and educators to try and take everything that exists and kind of condense it in different types of classes, online courses, books, and whatnot to like have a sort of unified explanation of how all of this works together. So if you're interested in this, we have our kickoff this Friday, March 21st, but you can also go to summerprotocols.com and get all the info. And then all the research we've published over the past 2 years is just up there and free for people to read. But yeah, it has been really exciting to try and think through like, okay, how should we think about Ethereum better? And one unexpected side effect of the program is a lot of like really smart people who don't necessarily care about blockchain, or even like some of them just straight up don't like crypto, have been like really willing to engage with us. And I found like talking about Ethereum problems through the lens of like, I have a protocol and it has these problems has been really helpful to like learn from them and exchange with them, rather than saying like, okay, this is like a crypto thing or like a crypto economic problem that we're trying to solve. So yeah, that's the idea behind Summer Protocols. It's run by Venkatesh Rao and Timber Shroff this year. So yeah, check it out.
Yeah, I remember listening to the episodes that we put out on Baikless about some of these researchers that went out and did their research about protocols, and then learning about kind of the connection points between seemingly very disparate ideas as it relates to protocols. And a protocol is already something so incredibly meta. Like Ethereum isn't one thing, it's actually a collection of things being held up by all these different client teams. It's something very meta. And then now we're talking about learning about protocols. So we're already getting even more meta than that. And so like kind of learning from these perspectives of these researchers, protocol researchers, it felt like kind of like touching the metal of the universe. Is like something feels very close to like the bytecode of how this universe is working. And so I thought it was very, very interesting. I never got any sort of education about anything related to that anywhere else other than some of the episodes that we did.
Yeah, and maybe one last thing on that, like Venkat framed it really well. It's like, if you think of the fields of economics, before we had this idea of supply and demand, people still bought and sold stuff to each other, right? So you could maybe walk around the world and be like, oh, this person's selling cows and this person is selling boats and whatnot. And like, you could build an intuitive sense of like, oh, more cows means like the cow price is lower. But then, you know, you kind of have Adam Smith come in like, okay, like we can formalize some of these concepts and say like, this is a way to think about these things that are already happening. This is, I think, like the cleanest, most possible example. I don't know that we'll get something as concise for protocols, but that's a rough idea, saying like, you know, protocols exist. People obviously work on them, they improve, but they are kind of different to like the way they're instantiated. Like the best practices for software development don't all apply to Ethereum, and the best practices for like how you are like the legal practice don't all apply to like international relations and like how you do like, you know, multi-nation protocols in terms of conflict. So I think trying to surface like what is a better way to frame those things is the goal. And yeah, hopefully this cohort gets us a bit closer to that.
Tim, thank you for joining me on Baikless today.
Yeah, thanks for having me.
Baikless Nation, you guys know the deal. Crypto is risky. You can lose what you put in, but nonetheless, we are headed west. This is a frontier. It's not for everyone, but we are glad you are with us on the Baikless journey. Thanks a lot.